This lesson is part of a series that describe the graphs of polynomial functions. This lesson explains the relationship between the factors and zeros of a polynomial function and how these relate to the graph of the function. The zeros of a polynomial are the values of its variable that make the function equal to 0. For example, this function is equal to 0 for x equal 2. In order to see this, substitute x equal 2 into the function. 2 cubed is equal to 8, and 2 squared is equal to 4. Then negative 3 times 4 is negative 12, and 8 plus 4 is 12. Finally, 12 minus 12 is equal to 0. So x equal 2 is a 0 of this function. If you know the factors of a polynomial, it's easy to find the zeros. For this example, set each of the three factors equal to 0 and solve these simple equations. Notice that a factor x plus 1 defines a 0 x equal negative 1, and a factor x minus 2 defines a 0 x equal plus 2. Finally, since these zeros are real, they are x-intercepts on the graph of the function. In this example, the exponent of 2 means the factor x minus 2 is repeated 2 times. The x plus 1 factor defines a 0 at x equal negative 1. The x minus 2 factors define a 0 at x equal plus 2. However, notice that the graph is tangent to the axis at x equal plus 2. Whenever a factor is repeated 2 times, or an even number of times, the x-intercept is a tangent point. Here's an example of a fourth-degree polynomial where the factor x plus 1 has been repeated 2 times. So there's a tangent point at x equal negative 1, and single x-intercepts at x equal plus 1 and x equal plus 4. In this example, the exponent of 3 means the factor x minus 2 has been repeated 3 times. The factors of x minus 2 define an x-intercept at x equal plus 2, and the graph has an inflection at this point. At an inflection, the graph flattens out, crosses the axis, and changes direction. Notice that to the left of the inflection, the graph curves upwards, and to the right of the inflection, the graph has changed direction and is curving downwards. Whenever a factor is repeated 3 times, or an odd number of times, the x-intercept is an inflection point on the graph of the polynomial. Here is an example of a fourth-degree polynomial where the factor x plus 1 has been repeated 3 times. So, there's an inflection point at x equal negative 1, and a single x-intercept at x equal 3. Finally, another important point to include on the graph of a polynomial function is the y-intercept, the point where the graph crosses the y-axis. In this example, the y-intercept is at plus 4 on the y-axis. This is equal to the product of the constants from each of the factors, plus 1 times negative 2 times negative 2 equals plus 4. This is always true. The y-intercept of a polynomial function is the product of the constants from each factor. For this function, the x plus 2 factor is repeated 2 times. So plus 2 is included 2 times in the product. The y-intercept is plus 24. For this function, the leading coefficient is negative. So a factor of -1 is included in the product. The y-intercept is -18. This lesson has been brought to you by the Math Department of Moreau Catholic High School, a Holy Cross school, bringing hope, building respect, being family, educating hearts and minds.